All right, guys. I spent a little time trying to figure out what I actually want to do with this to get this through. I've washed the body on a couple of parts. I found another RAM that I needed to use from my parts bin, stuff like that. And I have all the parts on the table. Ordered some replacement pieces, stuff like that. I have some extra fittings in case I break any or something like that. So everything's kind of accounted for now and kind of everything in place. And the big struggle I had was how the hell do I change this? Because I don't want to have these wires captured in the frame anymore. And I want to come up with a couple ideas. I was coming up with some ideas, and the best thing I think I figured out how to do is we're going to switch over when we go through the frame to some of this cable wire, this flat wire, because that fits through the frame hole perfectly. So that fits through. I have connectors on both ends, and now that I'm looking at them, they're super tiny. I've got a couple different kind of connectors. I like this particular style the best of them. It's a cable FFC 11 position, 0.5 millimeter pitch, 2-inch connector, 0150200790-ND. So I like this one particularly. It seems to work out well. 11 position, just flat cable, 0.5 millimeter pitch. That will fit through the frame really nice. But now I'm thinking I should make a daughter board on both sides of this cable so I can plug everything in on this top side and then plug this all in on the bottom. And the whole thing becomes very separable and nothing's trapped like it is now. And I like that idea. I was really into it. And when I run with that, I have to look and say that there are 11 wires going through this eventually. 3, 4, 5, 6, 7, 8. These 8. And huh. Alright. Some are 3 wires to spare. Wow, I'm an idiot. So that's supposed to be there. Somebody decided to do something a little different on that. Now I'm confused. Because I have that. And unless I'm just confusing what the hell I had. I'm pretty sure I had 11 wires coming through this thing. But if not, that's fine. We have 8 there, and then I had another 4 here, but only 3 of them being used. Disregard that. I have 8 at least. I have 11 potential, so I got 3 spares in case for some reason something else had to run through it. I could have sworn I had the eyes separately from going through this frame, but I guess not. Guess they were all going in? Yeah. So I screwed up my count that way, because this is the eye harness. It was just outside of the grip frame when it should have been up and through. Not a problem. But yeah, I have 8 wires to deal with. I have 11 possibilities, which is great. So 1, 2, 3, 4, 5, 6, 7, 8. So I got to label 8 of these. I'm still going to make daughter boards. I could probably go even smaller on these now. I don't even have to use these that I have, which is fine. But run what you brung, kind of. And the daughter board is going to work kind of the same way. So I'm going to have 8 pins. See that, right? Run them this way. Going to have a plug connector, which could have sworn I had 11 that I needed, but that's fine. That's going to go to that. This is going to have some kind of little breakout board on it. My sizing is going to be a little under 3/4 of an inch, like 0.725 by this. It's mounted to this side, so it's going to run down the front. I got pretty much the whole run. If I can do it by like 1 inch, I'll fit this connector on one side of it. And then we'll do these little plugs, these little JSTs that you see in the standard paintball markers. And we'll convert all this stuff to be males and just have a bunch of female plugs on this board. So you have 3 for the eyes. Then we're going to have 2 break out of it for the micro switch. Those are 5 wires. They actually get tuned into the board, so we're going to have more than the spacing we need. But we'll just run it as far as we can. The solenoids have 1 common ground. Two wires going back. 2 big black wires are the solenoid wires. Then they switch to tinier red wires, and they go back to black wires, which is fine. They share a common ground with these wires. So we'll do 2 mess. We have 2 more for the Hess sensors. I'll tie the ground back on this board so I can just run wires straight and not do any of this kind of atrocities. In lines 2 for the Hess sensors, I need a 3-pin for the solenoids. Do the center ground, and then that ground's going to connect to the ground on these on the board. The eye ground connects to this ground on the board. So we'll run it that way. And those connect together, those 3. Oh, they also connect to the big ground. All of these grounds are going to connect together. That cool. So all the grounds will connect together on the board when it gets there. And we won't do this. We'll just have individual wires running to each one of these now. So you can unplug it and pull certain parts out of the system, like the solenoid pack or the Hess sensors and stuff like that. Anything else running. So these 2 are the solenoid. This pink one's the main vein for the ground. That settles a lot of ground wires. This blue wire turns into one of the Hess sensor wires, I'm pretty sure. Yep. Hess sensor wire 1. The other blue one that's the main ground. This brown wire is Hess sense connector 2. And then these 2 wires are for the eye. So I'll have switch accounted for, which one of these blue wires runs all the way through for the switch. Eye accounted for, all 3 wires. They ground in. Hess sensors, both of them accounted for. There's 4 wires there, technically 3 wires. The solenoid, same way, both accounted for. I'm gonna make this one connector so you can't get it backwards with the solenoids. I just think that would be smart. The Hess sensors, I think it'd be better to have them so they go backwards. If you put the wrong one in the wrong spot, all you have to do is plug the wires in the opposite direction, and it works. But the solenoids, I don't want to do that. I want to make that more consistent. That's why I want to go 3 wires on that, 3 wires on the eye, 2 on the 2 on the switch, and 2 Hess sensors. And that's all of the components that are there. And then we have an 8-pin little one of these, not the 11 that I bought, going out to the other daughter board, which is going to live in here. And toss this in. That comes in through the top there. I got some space on top of this, but got about 1/2 inch comfortable. By an inch, maybe. I got 3/4 of an inch. Stays in here. Maybe I get rid of this top too. So I can essentially use the same board on this side as well. I just don't need as many of these to do what I need to do on that side. But I could probably go smaller as well. What would the benefit of that be? Just trying to think about this. Really might pay to just make another cover on this thing as well. That doesn't have this big hole, just has a much smaller hole for whatever the hell I'm doing here. I'm thinking about putting this inside a hollow tube that comes through here, and that's like more protected than it is now, and these wires aren't exposed like they are in the original setup. If I do that, I can run that same 1 inch by 3/4. And that's my max, and that's pretty good. And I'll build the other one. I'm not even going to build it with plugs. The other one, I'm going to build it straight to go directly to these 8 wires. So I just need 8 of them that go to my same thing. So I'm going to have the main ground, which is going to be 1 pin that goes to the pink wire there. My 2 solenoid triggers. And I'll make it so I just solder direct these wires to the board, and this plug is part of this board directly, and that all stays in the housing. 2 solenoids have to go to it. I guess I should do them down here. 2 solenoids. So down here I have 8 pins. Ground. Got my 8-pin connector. I'll link ground to ground. Sol 1. Solenoid 2. Call that trigger. And then I have S1, S2, and I plus minus. And that would be the 8 pins plugging into here. Goes to that, and we are all set if we end up doing that. All right. Looks good. I think I have the game plan. Got to switch what I did with these. I got to get a couple connectors of there. That's why I'm going to have 3 JSTs and 3 singles. Unless I 4-pack this. No, I think it should be fine that way. The head sensor should be separate. Then you can screw with them. The switch, if you don't figure out where to put the switch in the switch, then you're being an idiot on this one. Or I'm being an idiot on this one. So I think I'm okay. Solenoid is a 3-pack. Can't get it wrong. Eyes you can't get wrong. And yeah, that's it for the layout game. Let me try to put this board into a program to get made. And we'll go from there. Alright guys, this is now my 5th attempt at doing something that an 8-year-old can do, and that's record my screen and make it go on the internet eventually. But here we go. So this is the Easy EDA software. It's part of the JLC PCB stuff you see advertised by a lot of guys on YouTube, and it's pretty dead simple to use. I'm going to say that. That's why I'm using it in the first place. It's basically the cost of shipping to make these boards, and it's not very hard to use. This is an incredibly basic circuit board that we're making here. There's only connectors on it. There's nothing else but wires, or wire runs and connectors. So from my previous failure of not recognizing that I don't have 11 wires going through, but I only have 8 wires going through, I had to change my connector. I couldn't find a vertical connector that was made by Molex that's available anytime soon, so I had to switch over to a side-mounted one, which isn't the end of the world. I went with Molex. They had some vertical ones that were some off-brands, or brands I don't know. Maybe they're not off-brands, but if this one worked, I would have grabbed this one, but nah. But this was a Molex. I trust the Molex stuff. You see Molex and JST and all the paintball stuff, so it's one of the bigger brands for this shit. And it has these little side solder pads to just like lock it down to the board as best it can, which is, you know, I think good. So we're using that as the 8-pin side mount, and then we're using the little JS2 2-pins, which this is the 1.5 millimeter ones you find on Angels and 90-something% of other paintball markers. They sometimes use the other one, the 1 millimeter, and maybe the 2 millimeters on off guns, but most guns are the 1.5. And here's the 3-pin that we're going to use. So if you look at this connector, I identified what each wire was and where it went. First one is the brown eye wire. Brown eye. Alright, first one's the eye wire, the brown one. Fuckers. Going into the eye. The second one is pink, which, brown and pink next to each other, that's good. My mind's in a good place right now. But second one is the pink wire. That's the common ground for everything. So that is grounding to the middle wire of the eye, and I just always put it on all the 2s. So every 2 is going to be my ground. I'm going to get some flying leads and solder them in for all of these JST connectors. So I'm going to have the choice on which one I make the ground, which one I make the positive. I should call it the negative. It's not a ground technically. I guess it's a ground. I don't know. I'm not an electrician. But yeah, so I have that choice, and I'm just making the 2. The negative wire for everything. Going back to the pink, that's the 2. 3 is your trigger in, so your positive to your trigger. 4 is the positive to the first HES sensor, or HES 2, whatever one you want to call it, the Hall effect sensor at the RAM. 5 is the other Hall effect sensor, the positive. 6 is the black wire for the eye, so the eye is a reflective eye, or a bounce beam. So both the transducer and the receiver are in one unit, and it bounces it. So one of these wires, the brown eye, feeds one side, the black eye feeds the other side, and 2 is your
this is your ground that they both share a common ground. So that's the 6 one, the 7 and 8. These are a little chunkier, or at least I don't think they always are, but you'll see what I did on the board. These are going to solenoids 1 and 2. So I configured this in this way because the Hess sensors, I don't exactly know which one on the board is supposed to go to the one on the front of the RAM or the back of the RAM. And instead of just trying to make that work, I made them individual connectors where if they're wrong or I install them wrong, I can just switch Hess 1 and Hess 2 on the board and it's going to make it right. So I have a 50-50 coin flip. One's wrong, one's right. And that's all we need. The solenoid is a similar situation. I'm not exactly sure which one 1 or 2 is, but when I install them on the marker, they have individual plugs at the solenoids. So if I have it backwards, I just switch those 2 plugs and it will be fine. Same thing, it's foolproof basically. So that's the layout or schematic of this. And here's the little board we designed. It's 7/8 of an inch long, so 0.875 inches long, and it's 5/8 of an inch thick, or width, which is 0.625 inches. And yeah, it has the big, not the big, but the ribbon connector at the one end. I labeled all the stuff, the trigger, the eye, the solenoid, Hess 1, Hess 2, which is the Hall effect sensors. The bottom layer I used for the ground. I just made the ground a thick run because it's the ground. Might as well make it not a problem. And this is my run for the black eye wire. There's the top. So the solenoids, they have a thicker wire. That might be a 18 to 20 gauge wire. I just try to thicken them up best I could. These are a little thicker too, but I only have so much I can do going into the ribbon cable. I mean, the ribbon cable's rated for such a higher amperage than what's going to be produced. I'm not sure why they're so thick, but I decided to keep it that way. So hopefully you burn this out or the ribbon cable out versus burning anything else out for whatever reason. These here that you see, these are vias, so these are holes in the board that I linked everything through. And the reason I did that was because instead of making 2 boards, or instead of having the same board with a bunch of these connectors in the black box, which is not necessary, I can use one board in the marker in the frame. It's going to have these JST connectors in it, and this feeding the ribbon cable. When it feeds down into the black box, it's going to have the ribbon cable, and then I'm going to solder in to the main connector that connects to the actual Sandridge board. I'm just going to solder the wire leads into the vias ports instead of making 5 more connectors so the daughter board in there can be removed, because that doesn't really have to get removed. Once you remove the main board, the daughter board comes with it, with the already has a plug at one end. It's not stuck anywhere. So that makes it a little more reliable, a little less stuff to fail at that point, in my mind. And instead of trying to make 2 boards that are separate, I just have them all on one board. It's kind of universal, used in either situation. So I went through the connectors. This is the board that I ordered. I got 5 of them coming. They were basically, this is the price of shipping. I think it's $2 for the boards, and it's like $18 to ship, and that's almost fair coming from China like that. It should be here within a week and a half, something like that. I ordered it in black because there was no additional lead time for black, which is cool. And yeah, that's what the board looks like. I have 5 of them. I'm going to use 2. And I got a couple spares in case I screw something up, which is probably likely. So, is what it is. But yeah, that's it for this. This is just me getting the electronics situated, and hopefully the next video I make is going to be me actually installing this and separating all the electronics so it's all removable and all separable. So that's going to be hugely beneficial to us trying to complete this marker, and for future use of this marker if someone has to ever work on it. It's nice to not have this giant loom of wires that's stuck through everything and you can't fucking work on anything separately. Yeah, that's it for now. That's Andrew at Flory PB, and this is video 2. It's a little bit shorter than normal, and that might be a good thing. Alright, see you guys.